Like there may be equilateral triangles, there may be scalene triangles, there may be right triangles, isosceles triangles. There may be many different types of triangles. But what we are doing here, we are dividing all our triangles in two groups. I'm making two groups of triangles. In first group, I'm going to place right triangles, and second group, I'm going to place the triangles which are not right, non-right triangles. Okay. First of all, we will discuss the trigonometry which is based on right triangles. So here I'm writing trigo based on right angle triangles. You see here, first of all, we draw a triangle. It should be a right angle triangle. Here we have a right angle triangle. The main property of this triangle is one angle is 90 degrees. Let the name of this triangle be ABC. Like this. This is the right angle. We all know that in a triangle, in a right angle triangle, there is one side, this is the longest side. This side is known as hypotenuse. There are two sides, first and second. We don't have any fixed terminology for these two sides. Some people say that this side is perpendicular and this side is base, but I'm not going to use that terminology. Okay? What we do, first of all, we decide we are talking about which angles. If you can see, there are two acute angles in this triangle, angle A and angle C. First of all, you need to decide you are talking about which angle you are going to calculate for which acute angle. You are going to calculate for angle A, for angle C. If you are calculating for this angle C, then this side AB is called opposite side, and this side which is adjoining to your angle C is called adjacent side. If you change your way of calculation, if you don't change for angle C, if you start calculating for angle A, then this BC will become adjacent side and this AB will become opposite side. You understanding or not?
Yeah.
Okay. So Kenzie, if we talk about three sides of this triangle, these three sides are opposite sides, adjacent sides, and hypotenuse. These are three sides. Now I want you to find out the ratios among these sides. Ratios among above sides. By how many ways you can find ratios of these sides? If you wish, you can find ratio of opposite side and hypotenuse. Okay. If you wish, you can find ratio of adjacent side and hypotenuse, or if you wish, you can find ratio of opposite side and adjacent sides. Okay. In Trigo, we calculate these three basic ratios. These are called basic ratios. These are the three ways by which we can find the ratio of the sides of a right triangle. What we actually do, we just name this ratio as sine, S-I-N-E sine. The actual name is sine, S-I-N-E sine, but we don't use the whole term sine, we use the abbreviation part of this, that is sin, sine. The pronunciation is same, sine. Okay.
Okay.
The second ratio is known as cosine, but we don't use the full name, we only use cos, cos, this one. The third ratio is called tangent, but we don't use the full name, we just use the short form and we call it tan. So there are three basic trigonometric ratios which are called sine, cos and tan. Sine is dependent upon opposite side and hypotenuse, cos upon adjacent side and hypotenuse, and tan upon opposite side and adjacent. Okay.
Okay.
So your voice is too low, I'm not able to hear it properly. Can you hear me properly?
Yes.
Okay. So these are three basic ratios. We talk about the reciprocals of these ratios. The reciprocal of this opposite and hypotenuse will be written like this. This will be hypotenuse divided by opposite. The second reciprocal ratio will be, as you can see, hypo divided by adjacent. And the third reciprocal ratio is, what will be that?
Adjacent over opposite.
Adjacent over hypotenuse.
Opposite.
Oh, sorry. Adjacent over opposite. You're right. Okay. We have named this ratio as cosecant or just cosec as a short form. We have named this one as secant or sec as short form. And we have named this one as cotangent or cot in short form. Okay. Look here. These words sine, cosine, tangent, cosec, sec and cotangent. All these are Latin terms. As you know, our initial mathematics was developed in Greek, and at that time they used a language called Latin. So all these terms are taken from that language only, Latin. Okay.
Okay.
So I'm just removing this screen. I'll be back to this screen in a minute or so. You see, in your first question, in first very basic question, what they ask you to do, they just give you a triangle like this. It's a right triangle, ABC. As you are well aware that in a right triangle, the main property of a right triangle is that anytime we can apply Pythagoras theorem in it. You know Pythagoras theorem?
Yeah.
What is that?
A squared plus b squared equals c squared.
Yeah, it is adjacent side square plus opposite side square equals to hypotenuse square. Kenzie, the main point of applying a Pythagoras theorem in a triangle is this. If we know two sides of a triangle, then using the Pythagoras theorem, we can calculate the third side. Okay. Suppose I am giving you this triangle. In this triangle, you are given that first side is 12 centimeter, second is 13 centimeter. You need to find all trigonometric ratios. All T ratios. Okay. So to find all T ratios, you must know what are the values of all three sides of the triangle. But here you have only two values with you. So using Pythagoras theorem, you can calculate the third side. Can you tell me what should be the value of third side?
It should be 12 squared plus o squared equals 13 squared. So
Okay. What should be the value of third side? Okay, let me calculate it for you. So we can take out of these two sides, this one and this one, we can take, right now we can take any side as opposite or any as hypotenuse.
It's 20.
This is 12 square, is 13 square. What is 13 square?
169.
And what is 12 square?
44.
If we transfer, it will become minus.
25.
So O is what? 5 centimeter. So last side, third side can be taken as 5 centimeter. You understanding or not?
Yeah.
Okay. Now I'm going to calculate trigonometric ratios for you. So I will calculate the first trigonometric ratio, that is sine. So do you remember what is the
Sine
formula?
hypotenuse.
What is the formula?
Opposite.
So can you please be a bit loud?
Opposite.
Opposite
Hypotenuse.
divided by hypotenuse. Okay. So tell me, which side is opposite side?
So what angle though?
Yes, to what angle? As I have just told you that I'll get back to this side. You see, I have written sine here only. This is merely a definition. It can never calculate a numerical value for us. Because if we want to calculate sine, then first of all, we should know we are talking about which angle. Suppose I take this angle as theta, then I should place theta here. Only then I will be able to calculate the complete ratio. So now my formulas are complete. I go back to the question now. I calculate for C angle first. For C, what will be the value of sine C?
Sine C, it would be 12 over 13.
12 over 30. And what will be the value of cos C?
5 over 13.
5 over 13. And tan C?
12 over 5.
12 over 5. Okay. Now, we can also calculate the reciprocal of these angles, but before calculating the reciprocal part, I will calculate sine and cos for other acute angle, that is angle A. That is angle here you see. In this triangle, what will be the value of sine A?
It would be 5 over 13.
5 over 13. And what will be the value of cos A?
12 over 13.
12 over 13. And tan A?
5 over 12.
5 over 12. Kenzie, if you can see all these values carefully, like for example, if you just look at the value of sine C and cos A, you can conclude a very important trigonometric relationship.
Right? They're the same.
They are same. So this information will lead us to a very important trigonometric relationship. This relationship is called complementary relationship. We are going to discuss complementary relationship in trigonometric ratios. What is this complementary relationship? I just continue with the previous example. I'm drawing the same triangle here. The same triangle that we have just finished. This is 12 centimeter.